Hello, sixth graders. Welcome to Chapter 8, in which we'll be discussing surface area and volume. And in Section 1 specifically, we're looking at three-dimensional figures. That's kind of the fancy way of saying, you've probably heard of it this way as 3D, maybe going to see a movie in 3D. Okay, that just means three-dimensional, where we're not talking about flat things anymore, but things that are in three dimensions, that X and Y and Z plane. We won't get too complicated, just kind of work on how to draw some of those shapes. So taking a 3D image and putting it on a 2D piece of paper, and some other things where we're looking at where we're looking at faces, edges, and vertices of solids. So I'll explain those here in this lesson. Starting off with a little bit of vocabulary in a diagram here, it says a solid is a three-dimensional or 3D figure that encloses a space. A polyhedron is a solid whose faces are all polygons. Poly, remember, means many, and gon refers to shape, so a many-sided shape. And here are those three terms that I had read in the learning target. A face is a flat surface of a polyhedron. So, for example, if this was maybe visualize this as a Kleenex box, it would be the top of the Kleenex box, obviously, before you opened it up because there's no hole in it. All right. But polyhedrons have different faces. This is just an example of one of the faces, the top face here. You could look at the front face, or the sides, or the bottom, or the back. In this section, you'll have to kind of do a lot of visualizing with these shapes and being able to almost manipulate them in your mind. Sometimes it does help to look at an example. Sometimes I look at a Kleenex box or a cereal box or anything like that when I'm comparing these shapes to a problem. Edges are just line segments where two faces intersect. So here's an edge in blue here. Here's an edge. Here's an edge. Here's an edge. Kind of get the idea. And vertexes are points where three or more edges intersect. So this is a vertex because there's 1, 2, 3 edges intersecting. So let's try an example and let's see if we can find the number of faces, edges, and vertices in this shape right here. Okay, so I'm going to try to use my pen here for highlighting. I'm not going to promise it's going to go perfect, but I'll try my best. So first, when I'm looking at faces, I'm gonna highlight the top here, the top of this shape, and also the bottom. Okay, you can think of these kind of as the bases. It's sitting on this one, and this would be the top. So there are two faces, the top and the bottom. And then where are the other faces of this? I'm going to put polka dots here for the side. There's another side over here. There's a front, which is I'll kind of polka dot around it here. Would be a front face. And then the one that people tend to forget about the most is the back. On the back side of this, and I'll kind of put it, polka dot it like this, there is another face on the back side of this. That's why it's tricky if I can't take this shape and click on it and twist it around, you can't really see that. But the total number of faces that I have is I've got the sides 1, 2, the front 3, the back is 4, and then I have the top and the bottom for 5 and 6. So I have 6 total faces: the 2 bases, the front and the back, and the sides. So 2, 4, 6. The next, I'm going to look at the number of edges. So let me erase some of that. So It's a little bit clearer to see here. And remember what the edges are. The edges are line segments where two faces intersect. All right, so let's use a new color here. I'll just use black. So the number of edges, let's count. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and don't forget about this back one that's got the dashed line for a total of 12. So edges, I have 12. All right. And then lastly, not every drawing that you're going to see will have these green dots, but in this example they do, and it's kind of nice. The vertex, or the vertices, is plural. How many vertices are there? Well, in this case, they're the green dots. And remember, the vertices are points where 3 or more edges intersect. So 1, 2, 3, 4, 5, 6, 7, 8. I have 8 total vertices. And they're the green points in this diagram. And sometimes I like to think of vertices as corners. Sometimes it's a little bit easier for students to think about vertices as corners of the shape, right? So that's all we have to do. We've got faces, edges, vertices of this solid. Is just number how many that you see there. All right, go ahead and pause the video next to see if you can come up with faces, edges, and vertices for this solid. All right, we'll start off with faces. I've got the front here and the back for 1 and 2. This kind of looks like a tent to me, so I'm going to call the 2 tops. I'm going to say top 1, and I'm going to call this right here, if I were to shade this whole thing, top 2. Okay, so I'm going to pretend that that's a tent, and I've got a top, the 2 tops of the tent. I've got the front and back of the tent, and then lastly I have the bottom of the tent. So front, back is 2, the 2 tops are 4, and the bottom give me a total of 5 faces. Okay, let me erase. Come on, eraser. Next, I've got edges. Count the number of edges. So I've got 1, 2, 3, 4, 5, 6, and then the 3 dashed lines, 7, 8, 9. I have 9 total edges. And then let me erase again. Lastly, I have vertices. So in other words, kind of like the corners. How many corners do I have with 3 or more edges coming together? There's 1, 2, 3, 4, 5, 6 would be on the back side there. So I have 6 corners or vertices in this shape. All right, if you have questions about that, please let me know. Moving on to the key idea today, where we're going to talk about the difference of a prism and a pyramid. And prisms are a specific type of polyhedron that has 2 parallel identical bases. The lateral faces are parallelograms. So you can see here, they have it colored in red is the one base, and it's parallel to its other base, and it's identical bases. And it says the shape of the base tells the name of the prism or pyramid. So since this base is a triangle, it's a triangular prism. Another example of a prism would be like what I was talking about before, like a cereal box. And the identical bases would be the top and the bottom of the cereal box. Now, that wouldn't be a triangular prism. A cereal box would be a rectangular prism because the base is a rectangle, right? Versus, another type of polyhedron would be a pyramid. And you guys have a pretty good idea of what a pyramid is. But a pyramid only has one base. Notice here that the base is in red. It doesn't have that same base on top. The lateral faces are triangles in a pyramid. And you guys have a pretty good idea of that. We're just giving it kind of a specific name now. And this pyramid is a rectangular pyramid because its base is a rectangle, right? So in this next example, we're going to go through how to draw a rectangular prism and a triangular pyramid. And we'll get some practice on how to draw other shapes as well, where we're taking, basically we have to make it so that it looks 3D, right? So for a rectangular prism, we'll break it down into a few steps here. And in step 1, it wants us to draw identical rectangular bases. I'm not going to promise you that mine are going to be perfect. Drawing on the sketch pad here is going to be a little bit tricky. So I'm going to try my best to get them identical, but I'm not going to make any promises here. So, all right, here's my hypothetical rectangular bases that are identical. Just go along with me. Next step, step number 2, I'm going to add in, so step 1 is in green. Step 2, I'm going to connect corresponding vertices. So I have 4 corners. I'm going to add in 4 lines then. So I'm going to connect these 2. I'm going to connect these 2, and lastly, these 2. Now you can kind of see that I've made that 3D almost. The last step is to change any hidden lines into dashed lines. Now, I'm not going to be able to do that because my eraser will erase this entire line. So I'm just going to add in black to show you where you can erase. So this back edge would be a dashed line. The back bottom one would be a dashed line. And the bottom side one would be a dashed line. And those are the hidden lines to dashed lines. So now it looks a little bit closer to, as close to 3D as we can get, I should say. But if you use your eraser, that should work well. Again, mine just won't work here digitally very good. So there you have it. It's a rectangular basis, and it's a prism. We've made it 3D now. So that's a rectangular prism. And the second one will do a triangular prism. A triangular pyramid. So step 1 says to draw a triangular base and a point. All right, triangular base. Again, please forgive me for my drawings. They're not going to be very good here. They're kind of tricky. Come on, don't erase. All right, there's the first step, triangular base and a point. Step 2 wants me to connect the vertices of the triangle to the point, right? I'm going to do a new color. Connect the vertices. So there's one vertice. There's another vertice right there. And the last one right here, connecting it to that point. And in the last step, change any hidden lines to dashed lines. Well, this would be my front face. So all the lines in the middle of that are actually going to turn into dashed lines. So again, you can use your eraser for this part, but change these to dashed lines because these would be on the back side. If you pretend this whole front triangle, this big triangle here, is the front of it. And there you've got it. You've got your triangular pyramid. It's got a base, one base of a triangle, and the vertices connecting to a point or to the top of that pyramid. Triangular pyramid. You'll have a chance upcoming here to draw some more of these shapes and solids on your own after we do the different views here in example 3. Okay, so example 3 says drawing views of a solid. Draw the front, the side, and the top views of this eraser. And sometimes it's actually helpful to have an eraser handy to do this, to be able to view it in different ways. But let's give it a shot here. It says draw the front. And if I were to look at the front of this, I'm looking at this portion of the eraser. The front view is a parallelogram, right? Just exactly what I outlined there. So should draw something that looks similar to this. Okay. The side view, which we would come over here for, and if you were to orient it a little bit to the right, is actually a rectangle. It's a pretty small rectangle. And lastly, the top view. So the top view, if you're just looking right down on it, is actually also a rectangle, but it's a little bit bigger than the side, obviously. So I'm going to make it a little bit bigger. And there you have it. That's just looking at different views of it. Again, one thing that I think of when I'm doing this is like if you've ever gone on to Eastbay or Nike websites, they have where you can look at the shoes like a 360 view, a 360 degree view. So you can take like, okay, this is going to be a really bad shoe, but they'll have this like diagram, something like this, I think I've seen, where you can click it. And once you click it with your mouse, you can rotate it and you can see, you can rotate it over, you can rotate it up, you can rotate it down. You can see all these different views of these shoes that this is kind of what I'm talking about is when I'm drawing different views of shapes, except they have it for shoes nowadays. It's kind of cool if you know what I'm talking about, or if you don't, check it out sometime. You can, it's pretty cool technology. All right, lastly, we're going to finish up with 2 through 5 in the on your own, practicing drawing some more solids. So why don't you pause the video now and try these out on your own. All right, for number 2, I have a square prism. So I'm going to have 2 bases, and they're going to be squares. So what I need to do is I need to start by making my bases. Here's one square, and then I'm going to make another square close to as square as I can get. And then I'll add my edges. So 1, 2, 3, 4. And then I would take my eraser and erase those hidden lines. And here I'm just going to put in the black spots so you can kind of envision that those would be the dashed lines there. Number 3 is a pentagonal pyramid. So a pentagon is a 5-sided shape. Okay, so I'll do my best here to draw a 5-sided shape. 1, 2, 3, 4, 5. There's a pentagon. If you think about the Pentagon in Washington, D.C., it's the 5-sided building. And then it's a pyramid. So I'm going to make a dot again. And I'm going to connect each vertice to that, each one of my corners of my pentagon to that dot. Okay. And then lastly, I'll erase any hidden lines. So in this case, it would be this back one, this back line that would be hidden. And then it'd also be the two back sides of my pentagon base. Because you can see these front 3 and the back 2 would be hidden. So 5-sided pyramid, pentagonal pyramid. Moving on to numbers 4 and 5, it says draw the front, the side, and the top views. So we've got front, we've got side, we've got top views. The front view for this triangular prism would be, if you're just looking at the front here, you would just see a triangle. I guess you don't have to fill it in really. The side view, if you're looking at just the side, you would actually just see the rectangle. And if you were looking at it from the top, it would actually, it's kind of cool how it would look. It's that this rectangle shape, but then you would kind of see that line down the middle showing, and that line would actually be the top, and you could see this side and you could see this side, the other side. Picture again a tent. This kind of looks like a tent. If you were flying above the tent, the top view, you would see the actual base of it, and you would see the top would just resemble this line, and you'd have both sides sloping downward. And then finishing up with number 5, the front, the side, and the top views. The front side, you would just see the triangle. That would be like this. The side would actually be the same. Sorry, that's a really bad triangle, but the side would be the exact same. And the top view, well, if you were to fly up here and look, you would actually see that its base is a kind of a square shape. And then you would see something like this, where this would be your very top of your pyramid in the middle here, and then you'd see the different sides going down. So there you have it. Takes a little bit of practice drawing these solids and making them look 3D, but I think you'll get the hang of it. If you have any questions, please be sure to let me know. I will see you next time.